Hello dear students, in this video I'll start with the fifth unit, which is Inferential Statistics. In this video we will see the meaning of inferential statistics, then what is the importance of statistical inference, and then what is population, sample and various terms associated with them. Now first we will see the difference between descriptive statistics and inferential statistics. In descriptive statistics, all those that we have studied in class 11, it will come under descriptive statistics. Descriptive statistics summarize the characteristics of a data set. So if we want to find the mean or the standard deviation or quartile deviation or median of a data set, now all those will come under descriptive statistics. On the other hand, if we take inferential statistics, in this various tools are used that is required to draw conclusion from a sample and generalize them to a larger population. So as far as inferential statistics is concerned, we can draw conclusions about a population from a sample which we collect from the population. So one of the most important application of statistics is it is making estimations about an entire population which is based on the information from a small sample. So if we want to conduct a research, if we want to conduct a study, it is not possible to get in touch with each and every object or each and every person in a population. So what we can do is we can draw a small sample from this entire population. Now let us study this small sample and let us draw conclusions from this sample which can be applied to this entire population. So that is basically called statistical inference. So far we have been seeing the terms population and sample. Now let us see what is this population and what is this sample. A population, it is a group of all distinct individuals or objects that you want to draw conclusions about. So population, it is not just the population of a country or population of a state or something like that. It is all those individuals or objects which the researcher is interested to study, which the researcher is interested to draw conclusions about. The number of individuals or objects in a population, it is called population size. Now this population, it can be the individuals in a state or in a country, or it can be the number of products manufactured by a company and so on. So that is why we call this population as a group of all distinct individuals or objects that is under study. And next we have sample. In statistics, we commonly use a sample. This sample, it is a small subset of this population. So a sample is a small subset of a larger set of data for making inferences about the large set. As I already mentioned, it is difficult for the researcher to go in search of each and every individual which the researcher is studying. If the researcher is studying about a disease in a state, he or she cannot go to each and every person to collect data. So what can be done is a sample can be drawn from the entire population and inferences can be made about this population. So here the largest set is the population out of which sample is drawn. And now we just now saw a sample is a small subset of this larger set, which is the population. The process of drawing this sample from this entire population, it is called sampling. So sampling, it is the process by which a sample is drawn from the population. So it is, now we have some important points to note. Every time the sample size is the number of objects or individuals in a sample, it is less than the population size. And then the population refers to entire group from which we want to draw conclusions. So here we have sampling. The meaning of sampling, it is a technique of selecting small group of population, that is a subset of the population, for estimating the characteristic without having to investigate every individual. So as I already mentioned, it is difficult for the researcher to go in search of every individual to study about a particular characteristic. So what can be done is a small group from the entire population can be selected. Now the process by which this small group is selected is called sampling. It includes selecting a group of people, events, behaviors, or other elements in which we are concerned to make our conclusions. It is not only people, sample can be events or behaviors or any other element or any object. It can be anything which the researcher is interested about. The use of this is we can extend our results obtained from the sample group to the entire population. Now we will see the steps involved in sampling. The first step is identifying and defining the target population. So based on what the researcher is studying, the researcher has to identify the target and define who all should be included in the population. The next step is selecting the sampling frame. Sampling frame is nothing but it is the list of every object or individual in the population. Now only when we have a list of all those, then we will be able to select a sample from the population. So that is the next step. The third step is choosing sampling methods. Now there are various sampling methods which are available. So based on how the researcher wants to choose the sample, the researcher can choose an appropriate sampling method. Next we have the fourth step, which is determining the sample size. Now this is very, very important. That is, we have to determine a proper sample size that will truly represent the population which the researcher is studying or for which the survey is made. Say for example, if there are 1000 employees in a company and if the study is about employees of a company, then the sample size can be a small percentage of 1000 people. On the other hand, if the population is itself only, let us say 500 employees, then in that case the sample size should be large enough to represent the population. So that is the fourth step. The fifth step is collecting the required data. So based on the results or the conclusions that the researcher is interested in, the data should be collected. Now we have various sampling methods. Sampling methods are broadly divided into two types. One is the probability sampling and the other one is non-probability sampling. In this probability sampling, every member in the population has an equal chance of being chosen in the sample. So here if we have a population, say 500 people, then each and every member, that is an object or an individual, will have an equal chance of being chosen in the sample. Let us say we need a sample of 50. So here every person will have an equal chance to be selected in the sample. Then we have the next type of sampling, which is non-probability sampling. Here not every member in the population will have an equal chance of being selected in the sample. Under probability sampling, we have, it is subdivided into some more types. The first one is simple random sampling. Again here all the members in the population are taken and each member has an equal chance of being selected in the sample. That is simple random sampling. The next type of sampling is called stratified random sampling. In this type of sampling, the entire population, it is divided into strata or subgroups. Now say for example, in a college there are 1000 students. Among these 1000 students, if there are 600 male students and 400 female students, we need a sample of say 100 students and we are studying about gender balance. So in that case, in this sample of 100 students, we need to have 60 male and 40 female. Only then it will be a true reflection of this population. So this type of obtaining a sample from the population is called stratified random sampling. The third type of sampling is systematic sampling. In this systematic sampling, say for example, if we have 1000 employees in an office and we want to select say 100 employees for the sample, then every 10th employee in the role will be included in the sample of 100. So that is called systematic sampling. In systematic sampling, every nth member or the nth object will be included in the sample. That is systematic sampling. Then the last type of probability sampling is cluster sampling. In this cluster sampling, the entire population, it is divided into clusters, various clusters, and some individuals or objects from each cluster, it is included in the sample. In cluster sampling, say for example, if a bank has got 50 branches, then among these 50 branches, any 5 branches will be chosen, and from each of these branch, some employees will be included in the sample. That is called cluster sampling. So these are the various probability sampling. That is, in all these types, each and every object or member in the population has an equal chance of being selected in the sample. Next, we have non-probability sampling. In this non-probability sampling, every member or object in the population does not have an equal chance of being selected in the sample. Under that, the first one is convenience sampling. In this convenience sampling, the researcher will include those objects or members in the population whoever is convenient to him or her. So the person who is conducting the research conveniently chooses the sample. That is convenience sampling. And now we have the next type of sampling, which is the quota sampling. In this quota sampling, it is similar to stratified sampling. That is, the entire population, it is divided into subgroups or strata. But then in this stratified random sampling, the sample is selected randomly from the population. Whereas in this quota sampling, there is no random sampling which is done. Here in this quota sampling, the members who are included in the sample, it is done using non-probability sampling method. Next, we have what is called purposive sampling or judgment sampling. Here the researcher himself or herself will judge who all can be included in the sample. That is purposive sampling. The next type of non-probability sampling is snowball sampling. In this snowball sampling, if the researcher does not have enough ways to obtain sample for a study, say for example, if the study is about child abuse, then the researcher will first go in search of one child, then that child will direct to still 2 more childs, then the next person will direct to few more others, so that all those who are affected will be included in the sample. Such a sampling is called snowball sampling. So these are the different sampling methods. Apart from this, there are representative, non-representative sampling, biased, unbiased sampling. Similar to probability and non-probability sampling, I have already made a video in detail on all these types of sampling. The link is available in the description. Now we will see what is parameter and statistic. So this is very important. If you see parameter, it is a characteristic or it is a numerical value for the population. So that is called parameter. It is a characteristic or of a population, or it is a numerical value which is taken from the entire population. That is with respect to parameter. And next we have statistic. So remember this PP. If it is parameter, population. If it is sample, yes, sample statistic. So statistic is a characteristic of a sample, or it is a numerical value which is taken from a sample and that is calculated only from the sample observations. So parameter, it is calculated from population observations, and statistic is calculated from a part of the population which is the sample observations. Say for example, if we take population mean, then it is a parameter, and if we take sample mean, it is a statistic. So a parameter, it is generally denoted by Greek alphabets. So if we have the population mean, it is denoted by mu. If it is population standard deviation, it is denoted by sigma. If it is population variance, it is denoted by sigma square, and so on. Whereas if we take statistic, it is usually denoted by English alphabets. So the sample mean is given by x bar, standard deviation is given by s, and variance is given by s square. And variance is given by s square. So here we have an example. Under a study of calculating the average income of people of some specific region, the mean income and standard deviation of these incomes, they are nothing but population parameters. On the other hand, if we take the mean and standard deviation of income of 1000 residents from South Delhi, which is a part of the population, then it is called statistic. Now this mean and this standard deviation which we obtain on the income of 1000 residents, it is statistic. We have another example, knowing the average height of adults in India. It is a population parameter, whereas if we find the mean and standard deviation of height of 50 Indian adults, so these 50 Indian adults are taken from the entire Indian population. This is sample statistic. So this is sample mean and this is a sample standard deviation when we obtain the value for 50 Indian adults. So this is with respect to population parameter and sample statistic. And now we will move on. Now we have what is called sampling errors. Now we are obtaining some values for population and for statistic. The difference between the population parameter and the sample statistic is known as sampling error. Now why we are worried about this sampling error? Because if the sampling error is large, then it means our sample is not correct. We have not drawn a correct sample from the population. We are drawing a sample from the population to estimate some values of the population or to draw conclusions about the population from the sample. If there is huge difference between these values, then we are having huge errors. Even randomly selected sample also contains sampling errors because random samples are not identical to the population in terms of numerical measures like means and standard deviation. So it is not that only non-probability sampling will have sampling errors. There are chances that even probability sampling will have sampling errors because of faulty sample selection. So this sampling error, it can be either positive or negative. One important point to notice, this error decreases as the sample size grows or as the sample size increases. Here is an example of sampling error. Sampling error is the difference between a population parameter and a sample statistic. So here we have the sampling error equal to x bar minus mu. If this difference is small, then we say the sampling error is small and our sample is good. If this difference is large, then we say our sampling error is also more and the sample that we have drawn is not a true representation of the population. Here x bar is the sample mean and mu is the population mean. Population mean is calculated as summation I equal to 1 to n xi upon n, whereas sample mean is calculated as summation I equal to 1 to small n, where this small n is the sample size, capital N is the population size. Sample mean is summation I equal to 1 to n xi upon small n. So the sampling error can be calculated by the difference between the sample statistic and the population parameter. As I already mentioned, we have the reasons for sampling errors. The population parameter, it is estimated differently by different samples, or it can be due to faulty selection of samples, or because of small sample size, or the sample results may have potential variability. If the population is itself variable to a great extent, and if we draw a small sample from the population, then the sample results also will have potential variability. Now we have statistical significance. This statistical significance, it is a measure of reliability of findings. That is, it shows how we can proceed with our study if we find a particular result now, whether it will be applicable for future or not. That is called statistical significance. It shows how reliable are our findings. When a finding is significant, it means that we are confident that it is real and the sample was framed wisely. Next, we have sampling distribution. Sampling distribution of a statistic, it is a distribution of all possible values taken by the statistic when all possible samples of fixed size n are taken from the population. So sampling distribution, it is a distribution of the sample statistic. In unit 4 we have studied probability distribution. There we used to see various values which the random variable x can take. It can take values 1, 2, 3, etc. And then we will have the associated probability of this random variable x. So this is a probability distribution. Similarly, here we have a sampling distribution, which is the distribution of sample statistic. Such a distribution is called sampling distribution. So here we will have various samples. Say we have samples S1, S2, S3 up to etc. And here we will have the sample statistic x1 bar, x2 bar, x3 bar and so on. Such a distribution is called sampling distribution. Now we will see standard error of mean. This standard error of mean, it measures how much dispersion there is likely to be in a sample's mean when compared to the population mean. That is, standard error of mean, it shows the deviation of the sample mean from the population mean. That's what it measures, the standard deviation of sampling distribution about the mean. It is given by the formula sigma m is equal to sigma upon root n, where sigma is the population standard deviation and n is the sample size. So this is standard error of mean. Last year in the sample paper there was one question asked where we have to find this standard error of mean sigma m when the population variance and the sample size were given. It was asked for 2 marks. And now what is the use of this standard error of mean? If we have a small value of this sigma m, standard error of mean, it gives us confidence that our estimation of the population mean is relatively accurate. That is, the population mean is equal to the sample mean. On the other hand, if this is large, if this value is large and standard error of mean, it means we have small number of observations and they vary a lot. And also the population estimation is likely to be inaccurate. So these are the implications of having a large standard error of mean. Next, we will see what is central limit theorem. The central limit theorem, it implies that the distribution of a sample, it leads to become a normal distribution, that is a bell-shaped curve, as the sample size becomes larger. When we consider that all the sizes of sample are identical, whatever be the shape of the population distribution. So as far as statistics is concerned, it is better if we have a normal distribution in our study. So this central limit theorem, it implies that any sampling distribution will lead to become a normal distribution as the sample size becomes larger. So a sample size of 30 or more is considered to be sufficient to hold central limit theorem. And as the population size becomes large, the prediction of characteristics of population, it becomes more accurate. So the use of central limit theorem is that when we draw a sample from a population and when we study a sample to draw conclusions about the population, if the sample size is large, then whatever we estimate about the population with the help of the sample, it will be true. So as the sample size becomes large, the prediction of characteristics of population, it becomes more accurate. If not true, it will become more accurate. As per this theorem, when the sample size increases, the mean of sample data, it becomes close to the mean of overall population. So this is the use of this theorem. This is a very, very important theorem as far as statistics is concerned. And next we will see confidence interval. We use the confidence interval to express the precision and uncertainty of a sampling process. So this confidence interval, we use how far we are sure about a sampling process and how far we are uncertain about a sampling process. It has three components. One is the confidence level, next is statistic, and next is margin of error. So here a confidence level, it explains the uncertainty of a sampling method. So we are not completely certain about a particular sampling method. So that is called confidence level. Say for example, if we have a 95% confidence level where we estimate the population mean as in the range 30, 33. The meaning is that we are 95% confident that the population mean will lie in this interval. So that is the use of confidence level. And next we have statistic. Statistic, we already know a statistic is a numerical value or a characteristic of a sample. So it is calculated from the sample to estimate the population parameter. So that is statistic. If we want to estimate, say, mean mu, then the statistic will be x bar. Next we have margin of error. It describes the accuracy of a sampling method, or it is the range of values above and below the sampling, above and below the sample statistic. So margin of error, it shows the range of values which is above and below this sample statistic. So if we have x bar plus or minus margin of error. So a margin of error, it is the range of values above and below the sample statistic. Say for example, in the same example, if we get the interval estimate of population mean mu as in this range 30, 33, then we have x bar minus margin of error, x bar plus margin of error. So here we are 95% confidence that the population parameter mu will lie in this confidence interval. Here x bar minus margin of error is 30 and x bar plus margin of error is 33 in this example. And here we have another example. Assume a news channel conducts pre-election survey and predicts that candidate A will get 30% of the vote. According to the news channel, the survey had margin of error of 10% and a confidence level of 95%. So here the meaning of this sentence is that the news channel is 95% confidence that candidate A will get votes in the range 20% to 40%. So 30 minus 10% and 30 plus 10%. Now we will see what is hypothesis. Hypothesis, this term we are familiar. In order to make decisions, it is useful to make some assumptions about the population. Those assumptions which we make about this population, which may or may not be true, it is called hypothesis. So they are tentative, declarative statement which is given about the relationship between two or more variables. So when we want to make some decisions about the population, we have to make some assumptions about the population. Those assumptions are called hypothesis. If based on the test that we carry out, if those assumptions comes out to be true, then we make an appropriate decision. If those assumptions comes out to be false, then our results will vary. So that is hypothesis. Under hypothesis, we have two types. One is null hypothesis and the other one is alternative hypothesis. So in this null hypothesis, it states that there is no difference between a parameter and a specific value. Now say for example, if we want to test whether a sample is drawn from a population having mean equal to 20. So the null hypothesis is H0 is mu equal to 20. So it states that there is no difference between a parameter and a specific value, or it states that there is no difference between two parameters. Or sometimes if we have two different populations and we want to test whether those two populations are same. In that case, we have H0 as mu1 equal to mu2. There is no difference between the mean of the two populations. So here H0 is a statement of no relationship. It explicitly says that the two groups that we are studying are the same. So these are different ways to write the null hypothesis. Next we have the alternative hypothesis. In this alternative hypothesis, it states that there exists a difference between a parameter and a specific value. So if we have a null hypothesis which states that mu equal to 20, then in the same test we have alternate hypothesis which states that mu not equal to 20. So that is alternate hypothesis. Or it may state that there is a difference between two parameters. So if we have two groups under study and if the null hypothesis states that there is no difference between the mean of the two groups, then the alternative hypothesis, it states that there is difference between the two groups. In other words, it says that the two groups we are studying are different. So based on the study and based on the test that we conduct, we may either accept H0 or reject H0. If we accept H0, then it means that this mu, it is equal to 20. And in this case, if we accept H0, it means that there is no significant difference between the two groups that we are studying. Accordingly, we have to write the result. On the other hand, if we reject H0, then the result will change. Here, in this case, the sample is not taken from a population with mean mu equal to 20, and in this case, the two groups are taken from different population. So like that, based on the results that we get, we have to write the conclusion. Now we will see about writing the hypothesis. Suppose a cake baked through conventional method has an average lifespan of mu days and it is proposed to test a new process of baking cakes. if this is the situation, let us write the null and alternate hypothesis. So as already given in the meaning for null and alternate hypothesis, the null hypothesis H0 states that there is no significant difference between the average lifespan of cakes baked through conventional method and those baked through new process. If the average life of the cakes baked through new process is, let us say, mu1, then H0 is mu equal to mu1. And the alternate hypothesis is there is significant difference between the average lifespan of cakes baked through conventional method and those baked through the new process. In this case, the alternate hypothesis will be H1 is mu not equal to mu1. So this is how we have to write the hypothesis, or in simpler terms we can write this way also. Now next we have degrees of freedom. Degrees of freedom, it is the number of independent pieces of information on which an approximation is based. Now degrees of freedom, it will be easy to understand only after seeing examples. Now let us take this example. Consider a classroom having seating capacity of 24 students. So let us take a classroom which has a seating capacity of 24 students. Among all these seats, 23 students are having a choice. 20 students can choose among these 24 seats, whereas the 24th student has no other go, has to occupy the only left out seat. So in this case, the degrees of freedom is 24 minus 1, which is 23. So among the 24 seats, 23 students are independent to choose, whereas the last one seat, it has to be occupied by the last student. So here the degrees of freedom is nothing but 24 minus 1, which is equal to 23. Now let us see next example. Pick a set of 4 natural numbers whose sum is 20. So here when we want to find 4 natural numbers whose sum is 20, we are free to choose the first 3 numbers. Say we can choose 3, 7, 4. Here this will add up to 14. So the fourth number has to be 6. We are free to choose these 3 numbers, whereas the fourth number is dependent on the result. Or we can even choose 1, 9 and 7. Whereas the fourth number, if we want to have a sum as 20, it has to be 3. So in this case, the degrees of freedom is 4 minus 1 equal to 3. So here degrees of freedom, it represents the number of independent pieces of information on which an approximation is based. So it is denoted by nu, and if the sample size is n, it is usually given by n minus 1. So if n is the sample size, then the degrees of freedom, it is given by n minus 1. And next we have level of significance. So as I already mentioned, first we write a hypothesis, then we have to test whether the hypothesis is true or not. So we will have a null hypothesis, say mu equal to mu naught, and an alternate hypothesis mu not equal to mu naught. Sometimes we will get the result to accept H naught, or sometimes we will get the result to reject H naught. So here level of significance, it is the probability of making a wrong decision when the null hypothesis is true. So sometimes this will be true, mu will be equal to mu naught, but based on our result we will get it as reject H naught. So this is called level of significance, or it is also known as type 1 error. So it is the probability of making a wrong decision when the null hypothesis is true, or probability to reject H0 when H0 is true. So these are the various terms which are important to be understood before starting hypothesis testing.